Okay guys, welcome. This video is going to show you how to get started with the Robot Virtual Worlds Labyrinth or Maze challenge. So first thing we need to do is we need to open the program. So we're going to find our Graphical Robot C for Vex Robotics 4.x on our desktop, double click on it, and it should open up. If you happen to get a message like this, you can just get rid of it. Click Do Not Show Again, and then click Cancel. All right. So first thing we're going to do is let's open a new file. We'll click New File, and we've got our new file. Next, we need to go in and we need to do a little bit of setup. So first thing we're going to do is we're going to go up to the Robot menu, and we're going to check actually, the communication mode isn't going to matter. We're going to go down to compiler target. And up until now, we have been doing physical robot. For this particular activity, we're going to change it. We're going to do virtual worlds. So we're going to click on virtual worlds. Then we're going to go back to robot. We're going to go down to platform type, and we need to verify that it is Vex 2.0 Cortex and also that it is natural language PLTW. So let's select that. All right, next, one more thing we need to do. Go to Window and go down to the middle option where it says select virtual world to use. You want to make sure that this is on Curriculum Companion. So I'm going to click that to select that. Okay. Now, once we've got all that configured, the next thing we want to do is save this file. So we're going to save this to our H drive in our robotics folder. I'll walk you through how to do that. We'll go to File, Save As. Then we need to go to our H drive. So the way to get there is we go to this PC. We find our H drive, our network location, and we know it's our H drive, our home drive, because it has our unique student ID number. So we double click on that. Then we go inside My Robotics, double click on that. And if you should see all the files that we used previously for our challenges. So what we're going to do then is we're just going to, where down here where it has a file name, we're going to put our name, and I'll just pretend my name is Joe Student. So I'll just write Joe Student dash maze, because we're going to be completing a maze. All right. Say save. Okay. So what we're going to be doing is completing a maze within Robot Virtual Worlds. And the way that we can bring up Robot Virtual Worlds is we have to actually click Download a Robot. So for that window to come up. So I'm going to do that. Even though I haven't put any code yet into the program, I'm going to do this because I want to explain this. So when this comes up, what we want to do is don't worry about logging in. What we're going to do is going to just go down, make sure that it says login locally, that this blue tab is checked or selected, and then go down to login as guest. We'll click login as guest. Okay. This is actually a cool program. It allows us to do some coding without actually having to do a build. We can use virtual robots instead. Now, there are different choices for robots, but we're going to be using the first one, the square bot. But just to give you a little show around the place, there's different bots you can use. But we're going to use the square bot. All right. Next, we're going to go over to the movement tab. And we're going to select Labyrinth Challenge. Now, there's a bunch of different challenges that you can do, but we're going to try to navigate through this maze. So click on Labyrinth Challenge, come down to Start Activity. And it shows the maze that we have to navigate. Now, this window is kind of cool. There are some different views that you can use. This is the first view. The second view is sort of a bird's eye view. I like to use this because it gives a good view of things. And the third one is one that allows us to sort of drag the mouse and pan around and see what's going on. Okay? All right. So what we're going to be doing in this is we're going to navigate this maze. So we're going to start here with the red stripes, and we're going to navigate to the black stripes. So that means we're going to have to go straight, make a left turn, go straight, make a right turn, go straight, make another right turn, and then go straight in. This is a boundary. It's not like you can go through that, okay? So we have to navigate our way doing turns. Okay. Now, once you have this up, you don't need to, X out of it. Okay. To get back to the programming, to the Robot C window, just click on it. To get back to that window, see it's still open right down here. I just got to click on it and then it comes back. So don't X out of it because then it makes you log in as a guest each time. Okay. So the first thing we're going to do, let's add a comment that basically we'll use as a title. This is going to tell us what we're doing. Okay. So we're going to navigate the maze. All right. Now, the first thing we're going to do is we're going to raise the arm on the robot. Now, this is a better view where you can see that. See this arm right here? We're going to raise that up. And the reason why is if we don't, it's going to end up bumping into the walls. And so we'll just get it out of the way. Okay. So first thing we're going to do is come down to start motor because it's a motor that controls that. We're going to select the correct port, which is arm motor. And the speed is fine. However, we need to put in a negative sign so that the motor goes in the direction we want it to, so that it lifts the arm. And then we need to add a weight. And I'm just going to drag up a weight. It says 1 second. I'll keep it at that. So then we click save, compile. This downloads it to our virtual robot. It brings up the window. I'm going to hit refresh. And when we play it, you'll see that it's going to raise the arm. I'm going to change views just so we can get a good view of that this one time. So when I click the play button, watch the arm will come up. Good. Now it's out of our way. Okay. So now we need to add some code that's going to make our little robot go forward to right about here. Okay. So what we need to do is we need to tell the motors to do their thing. So start motor. And we need to tell it what motor. So we'll go right motor. And we're going to go full speed. 1, 2, 7. And then we're going to bring out another start motor command. The left motor. And we'll tell that to go full speed as well. 1, 2, 7. And then we need a wait command. Now, I know from experience that a good wait command time is 3 seconds for this. That gets you right about where you want to be. And I found that out through trial and error. So, okay. Oh, you know what? I forgot something. I want to put in another comment that's going to tell me what this particular code is doing right here. So I'm going to drag a comment down and I'll just put it right above where I want it to go. There we go. And then I'm going to tell it, I'm going to say what's going on. So what's going on here? This is our first straightaway. This is a good way to organize your code so that if you have a problem with a part of it, that you can narrow in into, what area you want to work on. And I really like the graphical version of this because if you want to comment something out, that is, make it so that the computer doesn't use it, you could always just click on the number and that makes it a comment. Click on it again, and now it's a regular piece of code that the computer will read. Okay, so save, compile, download. And for this one, let's go reload. Then I'll hit 2, bird's eye view, fixed view, and then click start. And then it will run through the code. It'll lift the arm, and then it'll go forward for 3 seconds. Okay, good. Now we need to make a turn. We need to turn left. So I'm going to come back to the code. I'm going to bring down a comment. And let me see if I can get this. Okay. Then the comment is going to be describing what this code is doing. So this is going to be a left turn. So to do a left turn, we need our start motor commands to tell it which ports. And I'm going to do 127. Start motor, left motor, 127. Now, I'm going to need to make a change in the speed. And because this is the left-hand turn, we want the left motor to run in reverse. And if you remember from previous discussions, In order to do that, we have to put a negative sign in front of the speed, like that. I'm going to come down. I'm going to choose a wait command. And then I know from experience that just over half a second is a pretty good wait time for what's called a point turn like that. So I'm going to do 0.65. That's just over half a second. Half a second is 0.5. So now I'm going to save it, compile it, download a robot. Now I'm going to restart it, click bird's eye view. And now when I click it, it's going to run the code. It's going to raise the arm. It's going to do the first straightaway, go straight for 3 seconds, and then it's going to do a left turn. The arm is raising. It's going forward for 3 seconds, and now it's turning. Okay. We're getting there, okay? So next, we need to do another straightaway. Then when we get here, we're going to need to do a right-hand turn. Then we're going to need to do another right-hand turn, and then another straightaway to get into here, okay? So I've given you all the code that you need to do this. The next thing we would do is put in code for another straightaway. So we would get a comment. We would say second straightaway. And then we would bring in our code for straightaways. Now we know from this one up here, it's exact same code. Start motor, right motor, 127. Start motor, left motor, 127. Wait, and we have to determine the number of seconds. Spoiler alert, 3 seconds will get you there, okay? So I'll just do this bit for you. Start motor, right motor, 127. Start motor, left motor, 127. And then a wait command, and we'll say 3 seconds. Okay, so save, compile, download. Let's reset it, bird's eye view, play it. So raises the arm, goes forward for 3 seconds, turns for 0.65, goes forward for 3 seconds. Okay, so next we need to do a right turn. So we'll come down, get our comment, and we're going to call this first right turn. Then we need our code for a right turn. Now, incidentally, our code for a right turn is exactly like it is for a left turn, except we're not going to reverse the left motor. Instead, we're going to reverse the right motor. Okay, so start motor, right motor, 127. Start motor, left motor, 127. And then a wait time. And 0.65 we said for a good turn. Did I forget anything? Yep, I forgot my negative sign to reverse the right motor. Don't do that. Don't forget, because then it'll just keep going straight. So good thing I caught it. You will too. All right, so we'll click just before the speed. We'll click the minus sign, so it is reversing the right motor. Then we click save, compile, download, reset, bird's eye view, play. Arm raises, goes forward for 3 seconds, does a slightly over half second turn, goes forward for 3 seconds, and does a slightly over half a second turn. Okay, so guys, I've gotten you more than halfway there. You have all the commands that you need. Next, we need a straightaway. Is it going to be three seconds? Probably not. Probably a little less. That I'm going to leave that up to you to figure it out. Then we're going to have, once we get here, we're going to have to do another right turn. How do we do a right turn? Well, got the code right there. Then we're going to have to do another straightaway. So that's all I'm going to show you. You need to figure out the rest. You have all that you need. You can definitely do it.